Many times in class, you will be provided the reactants and you have to predict what the products are. To predict your products, the first thing you want to do is determine the type of reaction. So identify, is it a synthesis combination, decomposition, single replacement, double replacement, combustion? Number 2, remember, metals must always replace metals. Non-metals must always replace non-metal. The only exception is hydrogen. When hydrogen is in the front, it behaves like a metal. When hydrogen is in the back, it behaves like a non-metal. Number 3, single replacement. You must always use the activity series. Any reaction that occurs, the elemental form must always be higher than its ion form. One of the things we need to memorize to write correct reactions is the diatomics. Di means two, so that means there are two atoms. There are certain atoms that when they are alone, they occur in pairs. Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine will occur in pairs. So on the periodic table, it is hydrogen, and starting with their first gas, which is nitrogen, we'll make a little 7 going down the halogen group. If you have difficulty memorizing that, you could use the mnemonic, have no fear of ice-cold beverages, in which the first letter represents the diatomic. H for H2, N for N2, F for F2, O for O2, I for I2, C for Cl2, and B for Br2. So let's look at this first example. We're going to identify the type of reaction. We have aluminum, which is an element, and we have chlorine, which is an element. An element and an element will be a synthesis or a combination reaction. So aluminum by itself is Al. Since it's black on the periodic table, it's going to be a solid, plus chlorine, which is a diatomic when it's by itself. It is gas because it's red on the periodic table. Since this is a synthesis reaction, Al will combine with Cl. Since Al is a metal, this is going to be an ionic compound. So aluminum charge is 3, Cl has a charge of 1, crisscross. So this is AlCl3. Next, we need to balance the equation. The Als are balanced. We have an Al on both sides, but the chlorines are not. Since one side has 2, the other side has 3, we need to find a common factor, which is 6. I'm going to multiply the product, AlCl3, times 2. So this will give you 2 Als, and it will give you 6 Cls. So on the opposite side, I need a 3 in front of Cl2 to give you 6 chlorines, and a 2 in front of Al to give you 2 Al. So the balance equation is 2, 3, 2. The general format of this equation is a metal plus a nonmetal produces a salt. A salt is an ionic compound. Number 2, we have iron 2 chloride. This is an ionic compound because iron is a metal. So we need to find a symbol, which is Fe. The charge is given as 2 because this is transition. Cl charge is 1, crisscross. So this is FeCl2 plus potassium hydroxide. Potassium is a metal. So we need to find the charge of potassium. Hydroxide is OH1. So this is KOH. We have a compound plus a compound. So we know this is going to be a double replacement. in a double replacement, the metals switch with metals. So they're going to swap partners. So that means iron is going to switch partners with potassium. So iron's new partner is going to be OH. And again, we know the charge of iron is 2 because it's given here. Hydroxide is 1, cannot reduce, so crisscross. This is Fe, parentheses, OH, parentheses 2. Potassium's new partner is Cl. Charge of potassium is 1. Cl is 1. Crisscross, so this is KCl. We started with 2 compounds and we ended up with 2 new compounds, so it's a double replacement. Now I'm going to balance Fe. I have 1. Cl, I have 2 right here. K, I have 1. OH, I'm going to keep as 1 because it appears the same on both sides. On the opposite side, Fe, I have 1. Cl, I have 1. K, I have 1. OH, I have 2. So I need a 2 in front of potassium hydroxide. So when I put a 2 in front of potassium hydroxide, that gives you 2 Ks. It gives you 2 OHs. So the OHs are balanced. The Ks are not balanced, so I need to put a 2 here. So if I do that, there are 2 Ks, then 2 Cl. Everything is balanced, so 1, 2, 1, 2. Number 3, we have barium. Barium by itself, it's black on the periodic table, so it's a solid, plus magnesium iodide. Magnesium is a metal, so I need to find its charge. Mg charge is 2. I is 1. Crisscross. So this is Mgi2. So we have an element and we have a compound. So the element here is barium and the compound is magnesium iodide. Since barium is a metal, it needs to replace magnesium, which is the metal in Mgi2. An element and a compound, this is a single replacement. So barium is going to replace Mg, so I need to look up barium. And I need to look up Mg on the activity series. Barium is the element and is higher than magnesium, so this reaction will occur. So barium's going to replace magnesium, so barium's new partner is going to be iodine, so this is going to be Ba(I)2. Because the charge of barium is 2, charge of I is 1, crisscross. And we're going to have magnesium by itself, and it's a solid. The equation is balanced. This is a single replacement that is cationic because the metals were replaced. So number 4, we start with calcium hydroxide. So this is a decomposition. Because calcium hydroxide is a compound, we start with one compound. It's going to break down, so this is going to decompose. So if you have problems like this, if none of the products are provided, it is going to decompose into elemental form. If it does not decompose into elemental form, I will provide the products. The general format for this is a base breaks down into metal oxide plus water. And we could write the base as metal hydroxide. So in the previous series, you had to memorize this, but now you don't. So I will provide the products if it's something different like this. Calcium hydroxide is an ionic compound because calcium is a metal, so we need to find the symbol and charge. Calcium is Ca, charge of 2. Hydroxide is OH, charge of 1. Crisscross, Ca, we must parentheses because there's more than one hydroxide, 2. So here's my metal, here's my hydroxide. We'll produce a metal oxide. The metal here is calcium. Oxide is oxygen. Charge of calcium is 2. Oxygen is 2. They cancel out. So this is CaO plus water. Now we need to balance. There's 1 calcium on each side. There are 2 hydrogens. 2 oxygen because it's 1 plus 1. So this is balanced. So number 5 is pentane and oxygen. Pentane is a hydrocarbon, something like this. I will provide you with the name and the symbol on the test. Pentane is C5H12. Oxygen, you know, is O2. A hydrocarbon, which is carbon hydrogen, reacts with O2. We know this is a combustion reaction. So my products are going to be CO2 and H2O. So O2, CO2, H2O will always be the same. Now I need to balance. So I have 5 carbons, I have 12 hydrogens, and 2 oxygens on reactant side. I'm going to count the product side. On the product side, I have 1 carbon, I have 2 hydrogens, and I have 3 oxygens because there's 2 from the CO2 and 1 from the water separated by the plus, so you have to add. So we're going to balance the carbons. So if I balance the carbons, I need a 5 in front of CO2. That makes it 5 carbons. The carbons are balanced. Now I'm going to balance the hydrogen. I have 12 on the reactant side, so I need 12, so I put a 6 in front. 6 times 2 is 12, so my hydrogens are balanced. Now I need to balance my oxygen. 5 times 2 here is 10, separated by a plus. 6 times 1 is 6, so there's a total of 16. So on this side, I need 16 oxygen, and 8 times 2 will give you 16. So my coefficients are 1, 8, 5, 6. Number 6, we have calcium, which is Ca, plus oxygen, which is a diatomic, which is O2. Diatomics are elements, when they are by themselves, come in pairs. Since calcium is an element, oxygen is an element, this is going to be a synthesis or a combination reaction. So we have a metal and a non-metal. So it's going to make an ionic compound or a salt. So this is going to be calcium, charge of 2 because calcium is a metal. Oxygen has a charge of 2, non-metal. I reduce, so my product is CaO. Now I need to balance. There are 2 oxygens, so I need a 2 in front of calcium oxide, which gives you 2 oxygen, but it also gives you 2 calcium, so I need a 2 in front of calcium. So my balance equation is 2, 1, 2. Number 7 we know is a decomposition because we start with one compound and it has to break into little ones. So this is a decomposition. If the products are not provided, it will decompose into elemental form. If the products are provided, then you need to use what is given. When I have acids, acids will always decompose into a non-metal oxide and water. So on the test, if you have a problem like this one, I will provide you the products. If I do not provide you the products, it goes into elemental form. 2 hydrogens, 1 carbon, and 3 oxygen. This is 2 hydrogens, 1 carbon, and 3 oxygens. It is balanced. Next one, we have an element, and then we have a compound. So this has to be a single replacement. Since the element is a metal, this is going to be cationic. Remember, metals replace metals, so magnesium must replace iron. So magnesium new partner is going to be SO4. Charge of magnesium is 2, SO4 is 2. They cancel out. So this becomes just MgSO4, and then we are going to have iron. To see if the equation occurs, I need to look up magnesium on the activity series, and I need to look up iron on the activity series. If the element is higher than the ion, Fe is the ion here because Fe has a charge of 2, plus because it combined with SO4, which is a 2 minus, the reaction will occur. Mg is higher than Fe, so the reaction does occur. Now we need to balance this. If I balance this, there is 1 mg, 1 mg, 1 SO4, 1 SO4, 1 Fe, 1 Fe, so this is balanced. So number 9, we have AgNO3, which is a compound. We have calcium chloride, which is also a compound. So we know this is going to be a double replacement. It's easiest if you place the metal with the metal. So Ag's new partner is going to be Cl. G charge is 1. You have to memorize it. Cl's charge is 1. You need to memorize it, so it just becomes AgCl. Ca's charge is 2. NO3 charge is 1. Cannot reduce, so I crisscross. Ca. There are more than one polyatomic, so I need a parentheses and a 2. So we created 2 new compounds. So now I need to balance this. Ag, there is 1. I'm going to keep NO3 as 1 because it appears on both sides, and there's 1. Calcium, there's 1. Chlorine, there's 2. We're going to do the same thing on the opposite side. Ag, there's 1. NO3, there's 2. Calcium, I have 1. Cl, I have 1. So I need to balance my nitrates. So if I do that, I'm going to put a 2 here. That makes it 2 Ag and 2 NO3. My NO3s are balanced, but not my silver or my chlorine. So if I put a 2 here, that makes it 2 Ags. My NO3s are balanced, my calciums are balanced, and there are 2 chlorines. So coefficient is 2, 1, 2, 1. 10, it starts with our CN and H, so this is a hydrocarbon plus O2. We know the products are CO2 plus H2O, so this is a combustion reaction. So I need to balance this. There's 2 C's, there are 4 H's, and there are 2 O's. On the opposite side, I have 1 C, I have 2 H's, and I have 3 oxygens. 2 from CO2 and 1 here adds to 3. So I need to balance my carbons. I put a 2 in front. That's 2 times 1, so there's 2 carbons. Now I'm going to balance my hydrogens, so I'm going to put a 2 here. So this is 2 times 2, which is 4. So my carbon and hydrogens are balanced. Now I'm balance my oxygen. So from CO2, there are 4. From the water, there are 2 separated by a plus. So there's a total of 6. So I need a 3 here. So my coefficient is 1, 3, 2, 2. Number 11, we have potassium, which is an element. We have bromine, which is an element. So this is a synthesis or a combo. Since we have a metal and a nonmetal, this is going to be an ionic salt. So charge of potassium is 1. Charge of Br is 1. So it just becomes KBr. So we need to balance. There's 1K. 1K, there's 2 BRs, 1 BR, so we need a 2 in front. That makes it 2 times 1 for potassium, so I need a 2 here. There's 2 bromines, there's 2 bromines. Coefficients are 2, 1, 2. Next one, number 12, H2 is an element. H is a diatomic. It is by itself. It occurs as pair. Copper nitrate is a compound. So this is a single replacement. That is a cationic. So the hydrogen here is going to replace the copper. So that means copper is going to be by itself plus hydrogen, which has a charge of 1, is going to combine with nitrate, which has a charge of 1. That's going to be nitric acid. Now, since this is a single replacement, we need to look up H2 and Cu. H2 here is the element. Cu is the ion because it took a charge of Cu2 plus to combine with NO3 minus. On the activity series, the H2 is higher than Cu, therefore reaction occurs. And so my products are Cu or copper solid and nitric acid. Now I need to balance. So there are 2 nitrates, so I need a 2 here. That gives you 2 hydrogen and 2 nitrates. There are 2 hydrogens, 1 copper, so this is balanced. When you are predicting products, you want to first determine the type of reaction. Number 2, metals replace metals, nonmetals replace nonmetals. Do not carry subscripts through unless they are part of a polyatomic. So for example, sulfate is SO4. That is how you write sulfate, so the 4 goes over. If you have SO4 in a parentheses and there's a subscript 3 outside of the parentheses, so if we have something like Al and we have parentheses SO4 and there's a 3 and there's a 2, this 3 does not carry over, but the 4 is part of sulfate, so that does carry over.